Hi everyone, this is Siddharth. Thank you so much for watching The Diligent Educator. In this video, we'll be talking about electronic symbols, circuits, and very important, Ohm's Law. I would highly recommend you to go back and watch my previous video titled The Basics of Electronics in case if you have missed it. If you like the video, do hit that like button and do not forget to subscribe to my channel. Okay, so let's begin with the electric symbols which we are going to use in the circuit diagrams. Now there are various electric symbols which we use in various different circuits, but we will be talking about some of the basic symbols. Now the first one over here, if you remember, we talked about this in our last lecture or last video as well. This is how you draw an electric cell. One big line and one small line parallel to each other. The big line denotes the positive terminal and the small line denotes the negative terminal. Now you could draw it this way as well. This is perfectly fine. This will be the negative terminal and this will be the positive terminal. And if you remember from the last video, a series combination or cell, one after another, if you put, it becomes a battery. So how will you denote a battery? This is how you will be showing a battery. Okay. Next thing we have is key. Now what is key? Key acts like a switch in the circuit. Just like we have switch to turn on and off the circuit, we'll have key in a circuit that will turn the circuit on or off. Now there are two major types of keys which we use during experiments. First one is the tap key and the next one is the plug key. Let's see how do we denote tap key. Now this is how a tap key is denoted. You actually tap it. From the top when you tap it, this connection is established and the key is closed. So this is basically open tap key. And if I have to draw a closed tap key, this is how it will be. Wherein the connection over here will be established. So this will be a closed tap key. Let's talk about plug key. Now how does a plug key look? We have a device in which we'll be putting it inside. This is how we'll be plugging in the key inside, and that is when the circuit will be completed. So to show a plug key, open plug key, this is how we show it. This is an open plug key, and when we plug that key inside it, it becomes closed plug key. This is how you show a closed plug key. Always remember, whenever the key is open, there is no current flowing in the circuit, and whenever the key is closed, there will be current flowing in the circuit. Proceeding on to the next parameter we have here is resistance. Now basically resistance is an intrinsic property of an element. So resistance is not as such denoted. Resistor can be denoted. Okay. So this is how you denote a resistor. You will draw a zigzag line. That's it. This is how you will denote a resistor. If you remember from the previous video, resistance is nothing but opposition. So this symbol denotes the opposition or the difficulty for an electron to pass through. Next one is an ammeter. If you remember, ampere is the unit to measure electric current. Hence, ammeter is a device that measures electric current. Very simple. This is how you will be drawing an ammeter. And this is how you will be drawing a voltmeter. Again, volt is a unit to measure the potential difference. So basically voltmeter will be measuring the potential difference between two terminals. In some cases you can see an ammeter denoted like this. Even this is a correct denotation of ammeter. Having seen all the symbols that we use generally in some basic circuit diagrams, let's see a circuit diagram now. Over here you see a resistor R is connected in this circuit. This is a plug key which is open. Remember, open plug key means there is no current flowing in the circuit right now. And we will connect a voltmeter over here. A voltmeter, which is a device to measure potential difference, is always connected in parallel to the resistor. Now remember, in some cases the resistor is set as load or load resistor. Now this load can be any device. It can be a bulb, it can be a toaster, it can be a refrigerator, any device which work on electricity. This is the ammeter which will measure the current flowing through the resistor. Hence it is connected in series. See, if you can see that the current which will flow through the ammeter, that same current will flow through the resistor. So that the ammeter will give you the reading of current and the voltmeter will give you the value of potential difference between these two terminals. Now as soon as I close the circuit, as soon as I close the key, so this is a key which is closed now, the current will start flowing in the circuit. And if you remember from my last lecture, the conventional current which we show in the circuit always start from the positive terminal. So this is how the current will flow in the circuit. This is the clockwise direction. Having seen a simple circuit, let's use the same circuit to understand a very important law in electronics, which is Ohm's law. Now let's see the statement. The statement is very straightforward. It says that so long as the physical state of the conductor remains same, the potential difference across the terminals is directly proportional to the current flowing through the resistor. Now, you might have not understood what I have said just now. So we'll try to break that statement and try to understand it. So long as the physical state of the conductor. Physical state of the conductor means what? Physical state means the temperature, the length, the area of cross section and the material of the conductor. That should remain same. You cannot change the wire, you cannot change the material. The entire experiment should be done with the same wire. If that is the condition which you are maintaining, now why are we saying this? We'll come to that a little later. If that is the condition you are maintaining, then the potential difference across the terminals of the resistor, that is V, will be directly proportional to the current I flowing through the circuit. In other words, Ohm's law is telling us that V is directly proportional to I. We increase the voltage, the current will increase. Having studied the statement of Ohm's law, let's see how we are going to prove this particular law. So for that, we will be using the same circuit. Now you might be wondering that how will we get three different readings for voltage and current. So for getting that different reading, what we will be doing is we will be increasing the number of cells for every reading. Like for example, for the first reading, this is the setup. I measured the potential difference, I measured the current, and I found out that the potential difference comes out to be 0.5 volt and the current comes out to be 0.2 ampere. Now when I take the ratio of V upon I get it as 2.5. So now if we have to take the second reading, as you can see over here, I have included one more cell in the combination of the cells. So now I take another set of readings. Say for example, I got V as 1.25 volt from the voltmeter and I as 0.5 amperes from the ammeter. Again I take the ratio of V by I and I get it as 2.5. The third set of reading, again I have connected one more cell in the combination and I have got the reading accordingly. Again I can see that the V by I ratio in all the three readings remains constant, and this constant is nothing but your resistance. So from here, Ohm's law said that V is directly proportional to I. So in algebra, always when you have to remove the proportionality, we introduce a constant. So over here I am putting a constant which is R, as you can see over here. So I get V is equal to IR. This is the popular equation of Ohm's law. Now going back to the statement which says so long as the physical state of the conductor remains same. Why is Ohm's law asking us to make sure that the physical state of the conductor remains same? That is the length, area of cross section, material and temperature, because if any of these four changes, our resistance changes. And if resistance changes, can we afford to change the resistance? No, because in this particular experiment, our constant is resistance. We have to make sure that resistance remains constant. So the statement, so long as the physical state of the conductor remains same, the potential difference is directly proportional to the current flowing through the resistor. That was our Ohm's law. From the readings which we got in our experiment, if I try to plot a graph wherein I keep voltage on the y-axis and current I on the x-axis, and if I plot their values, I'll get a straight line passing through the origin. So that shows the direct relation between V and I. As you are increasing V, the I, that is as you are increasing voltage, the current is increasing. And if you take the slope of this particular line, you get the resistance, which is V upon I. A easier way to remember the formula is to draw a triangle and remember it this way. Now whichever value you want to find out, you have to just simply cover it. If I have to find out V, V is equal to I into R. I is equal to V upon R and R is equal to V upon I. So let's see some numericals based on the same and we'll wrap up for the day. The numericals which are based on Ohm's law are not very difficult as such, because there are only three variables. Out of three, two will be given to you and one will be asked. Like you can see in this particular question, they have given you the potential difference as 5 volts, current as 0.5 amperes, and they are asking you to find the resistance. Now remember the Ohm's law. Ohm's law tells us that V is equal to IR. Now from here we have to find out R. So it will become R is equal to V upon I. Remember that triangle? Use it to get the formula quickly. So we get it as phi upon 0.5, which comes out to be 10 ohms. So R is equal to 10 ohms. I hope you remember omega. This is how you denote the ohms. So R is equal to 10 ohms. See one more numerical in which resistance of the resistor is given as 120 ohm. I, that is current, is given as 2 ampere, and they are asking us to find the potential difference across the conductor or the resistor. Let's see. As we know the Ohm's law, V is equal to I into R, which is equal to 2 into 120. That comes out to be 240 volts. So the potential difference across the resistor is 240 volts. Now, do not forget to go into the description and click on that link of the document which I have provided. I have uploaded an exercise document. Do practice the exercise document. If you are facing any difficulties, post it in the comment section so that I can help you out with that. Having said that, do like, share, comment and subscribe to my channel. Thank you so much for watching. Have a nice day.